Hello, ladies and gentlemen, and welcome back. We are on question number 3 from our 2016 Friar contest. A median is a line segment drawn from a vertex of a triangle to the midpoint of the opposite side of the triangle. So we've got some pictures over here. A median through A goes and hits D because we can see that D is indicated as the midpoint of this opposite side, BC. Alright, so our first, we've got 3 parts here. First one's a light bulb, and then we have 2 written portions. In the diagram, triangle ABC is right-angled and has side lengths AB 4 and BC is 12. If AD is the median of ABC, what is the area of ACD? So this one over here. Alright, well, how do we find the area of a triangle? We use 1/2 base times height. Oh, we can draw a better base than that. There we go. Now, we can see that it's going to be a nice little height for our triangle. Over here, they tell us AB is 4, and that we've got a nice little right angle. So it's sticking up right out of the base, perpendicular to the base here. So, to figure out the area of ACD, we really just need to figure out this base length, CD. So then we've got our height and our base, and we'll be done. But of course, D is the midpoint of BC, and we know BC is 12. So DC, well, that should be half of BC. So 1/2 of 12, and that's going to be 6. So the area of ACD is 1/2 base times height. So we'll get 1/2 24. Or 12. So the area of this particular triangle is 12. Now that's not the only way you could do it. Of course, you could still figure out the base is 6. This is 6, and so is this. And you could figure out the area of the whole triangle with a base of 12. So 1/2 12 times 4 is going to be 24. And then you can figure out the area of this triangle here and subtract that away. You'll get 24 minus 12. You'll still get 12. Okay? But either way, we've got our answer. We can move on to B part. Okay. In rectangle EFGH, point S is on FH with SG perpendicular to FH. So FH is a nice little diagonal, and we are dropping a perpendicular from G. Okay. In triangle FGH, so the lower half of this rectangle, median FT is drawn as shown. So that means it splits G and H here. If FS is 18, SG is 24, and SH is 32, determine the area of triangle FHT. Okay, so FHT there. Okay, well, if I just take a look at, maybe introduce some color here. If I just look at FHG, that's it's a rectangle, so we get a nice little right angle here. That's very similar to what we just did a moment ago. Okay? We wanted this triangle, well, now we want this sort of triangle. So if I could figure out the base here and the height here, we'd be all set. Now, we're not quite given those lengths, but we should be able to come up with something. So let's draw our picture again. Just remembering to be careful to explain. In fact, we don't really need the rectangle part of it. They're just trying to tell us that there's a right angle at G. At least that's what I think so far. I'll add in E if I'm mistaken, but pretty sure we're fine. So we'll put T here. Okay, and then we want S here so that we get another right angle. And we've got 18, 24, and 32. Okay. So, and this here is S. Well, the 24 and the 32 gives me a nice little right angle, so I'll make a few comments here. FSH FGH and let's say GSF are seen to be right-angled triangles. Okay. Now, by Pythagoras, or by the Pythagorean theorem, if you want to. I prefer to say by Pythagoras. We can see FG squared should be 18 squared, SF squared, plus GS squared, so 24 squared. Now, 18 is 6 times 3, 24 is 6 times 4, so the answer should be 6 times 5 squared, using a 3, 4, 5 triangle. If not, grab your calculator, because remember, calculators are allowed, and you can quickly work out you're going to get 30 squared there. So, FG, the height for FTH, is going to be 30. Similarly, GH squared, that's the hypotenuse of GSH, is going to be GS squared, it's 24 squared, plus 32 squared, SH squared. And we can see that this is 3 times 8, and this is 4 times 8, so the answer should be 5 times 8, again using a 3, 4, 5 triangle. So we should get 40 squared. Okay. And so GH is 40. And that makes sense, because we'll have actually another 3, 4, 5 triangle, because if we add up 18 and 32, we do get a hypotenuse FH of 50. And this is a 3, 4, 5 triangle quite nicely. So, yeah, that makes sense that that's right-angled there. Okay, now what do we want? We want to split T here. So, HT is going to be 1/2 GH. So it's 1/2 40. That's 20. And then the area of FTH is 1/2 base times height. So we'll have 1/2 20 times 30. And that'll be 1/2 of 600. 300. We're doing the exact same way we did in part A. We found the base here, and we're using this as a height. Again, if you did A differently, you can apply the exact same technique. The only challenge here for B is finding the GH and FG lengths. That's all there is to it. Okay. So there we go, and I guess we're ready for part C. So what have we got for part C? There we go. In quadrilateral KLMNs, it's not even a rectangle anymore. Well, there's a lot going on here. Yikes. Okay, KM is perpendicular to LN. So these diagonals here are perpendicular, and they intersect at R. And then we've got some medians, KP and KQ, inside some triangles. And we know some lengths. LR is 6, RN is 12, KR is X, and RM is 2X plus 2. Interesting. And we know the area of KPMQ is 63. Determine the value of X. Interesting. I'm not quite sure where the medians are going to go with this. I suppose we'll have probably different ways of calculating the same thing. Some of them will have X's in them, some of them might not. Let's draw our picture here. Alright, so 2x plus 2x. Now we've got a nice little right angle here. I think that's going to be an important thing to start with. 6 and 12. I'll add in the medians later, because right away I see a way to calculate the area and equate it with x. So I have a bunch of little right angle triangles. So what was this? K L, M, and N. So triangle KRN, KRL. Well, let's do this in an organized fashion, otherwise it's going to upset me. KRL, LRM, MRN, and NRK are right-angled at R. So, what can we see? Well, the areas of KRL should be 1/2 base of 6 height of X. The area of LRM should be 1/2 base of 6 height of 2x plus 2. MRN, 1/2 base of 12 height of 2x plus 2. And NRK, 1/2 base of 12 height of x. So we can work these out. Change this to 3x. Change this to a 6x plus 6. And then 12x plus 12. And then a 6x here. And if we add all those up, that should be equal to 63, unless I was misreading it. Oh, KPMQ. There we go. So this thing in here. Oh, okay, I was very confused because I was about to answer the question without using the medians. And I thought that's not right. Okay. So, what can we do from there? So, I mean, maybe I don't need those right-angled triangles the way I've got them. But, actually, I think we should be able to still use that expression. Just we won't use 63. I think we'll have to double 63, but I'll see that in a moment. But I'm still going to add up all these things. So 3x, 6x plus 6, so 9x, 15x, 27x. So the area of, not triangle, but I guess quadrilateral KLMN is 3x plus 6x plus 6 plus 12x plus 12 plus 6x, and that should be 27x plus 18. Okay. So that's fine. That I misread the question. I was about to equate that equal to 63. I don't know whether or not that would have gone well. I guess x doesn't have to be an integer, so could have solved it. But I'm glad I figured out where the medians are coming in. So now, notice that if I draw this in again, and I draw our medians, we got K, R, M, N, L. Okay, let's not say notice that. Let's say we claim that area of I think this was a P and this one was Q. KLP is equal to KPM and the area of KQM is equal to the area of KNQ. Okay. So I'm pretty sure this is true. Let's just show it off. Well, indeed, if we consider any triangle ABC with median D as shown, I'm just copying the letter scheme from the first one, but I am not going to copy the fact that it's right-angled. If I extend BC out to a point here, maybe call it E, so that we've got a right angle, we've got an H here. Since BD is equal to DC, because remember a median splits the opposite side, we see having the same height A, or having the same height H, 1/2 HBD is the same as 1/2 H DC. Okay. It's quite a nice result that if you have a median, that the two triangles it splits it into are equal to, they have the equal area. They're both equal to 1/2 the total area. And this is not just true of medians. If you've got BD to DC as a ratio of, say, 1:2, you get that corresponding ratio in terms of their areas and stuff. But since median splits it with a ratio of 1:1, you get equal areas. So what does this mean for us? Well, this means the area of KLMN is equal to the area of triangle KLM plus the area of triangle KNM, but both of those, here's one of them, here's the other, both of those can be split into, or realize that they're just twice these smaller areas. So that's 2 times the area of triangle KPM plus 2 times the area of triangle KQM. So this is 2 times triangle KPM plus triangle KQM, but if I add those together, that's 2 times the area of KPMQ, the quadrilateral that I actually know the area of. So 2 times 63, so that'll be 126. So what are we allowed to conclude? 27x plus 18 is 126. Now I can figure out what x is. 27x, subtract 18 from both sides, we'll get 108. And 108 is a multiple of 27. We can even do this without our calculator if we want to. We'll just get 4. So x is equal to 108 divided by 27, and that is 4. Okay, so x is equal to 4, and I think that is all we were asked for. Determine the value of x. There it is. Okay, so I misread it at the start, and I started working with these triangles here, although I was going to have to anyway. But this is a lesson. Carefully read the question, because I feel like I started off a little bit wrong. But then we did wind up using the medians and simplifying it. Now, I have no idea what each of these individual triangles' areas are. It doesn't matter to me, because together they're 63, and individually they're each half of the 2 halves of my quadrilateral, or 2 parts of my quadrilateral. So it all worked out in the end. Okay. And most importantly, I did explain everything I was doing. So we've got one more question to go, one final question for our 2016 Hypatia, and that'll be question number 4. I will see you for that in the next video.